Hello, everyone. Thank you for joining us for Canadian Underground Infrastructure Innovation Center Academy webinar, which is called From Design Review to Turnover, Best Practices for HDD Inspection Services. My name is Inshik, and I'm today's moderator. Organized by Canadian Underground Infrastructure Innovation Center, the University of Alberta, and Benjamin Media Incorporated, QIG Academy offers classes, courses, webinars, and events to help further underground infrastructure educational opportunities across Canada. QIG Academy happens every third Thursday, and then our next installment is on December 18th. So please join us for that one. And for the full list of upcoming and the past webinars, please visit at qig.ca for more information. And the registration for QIG Academy Spring Summit is going to open soon, which is going to be held on March 3rd to 5th, 2026 in Mississauga, Ontario. And for more information for that, also you can visit qig.ca to learn more. And thank you to the 2025 webinar series sponsor. This time it's Ackerman. And now we will move on to the main presentation. I would like to introduce our speaker today, Ron Jensen from CCI Incorporated. With over 20 years of experience in trenchless technologies, specializing in horizontal directional drilling, Ron has contributed to a wide range of projects from fiber optic installations to some of the most technically demanding pipeline crossings. His career has taken him across Canada, Europe, and the United States, progressing through field and leadership roles, including laborer, driller, rig manager, and project manager. He currently serves as a senior construction manager at CCI Incorporated, where he leads a team of HDD inspectors, coordinates with multidisciplinary teams, and provides strategic oversight across complex trenchless operations. As part of the construction management team, his role is to coordinate with stakeholders, validate technical execution, and ensure alignment with the project specifications, safety standards, and client expectations. So please welcome Ron. And now, Ron, the floor is all yours.
Thanks, Justin. Thanks, everybody, for joining us here today. Happy to get invited and this opportunity to speak to everybody about HD inspection and construction management. So quick overview of the agenda. Today we'll discuss in general what HD inspection is, why we need it, the life cycle of the project and the HD overview of it, the three key phases, which are pre-construction, the construction phase, and then post-construction and turnover. We'll highlight some training, real-world examples, and give everybody an opportunity to participate in the Q&A. So if you think of anything while we're going through this that you'd like to ask after, please write it down and don't hesitate. Happy to make this interactive and answer as many questions as possible at the end. So quickly, what is HD inspection? So HD inspection, and I'm going to emphasize a little bit also construction management, as it's a bit of a group effort and not just necessarily one person on the project sitting on the site with oversight of it. HD inspection provides independent oversight to ensure the drill is executed safely, accurately, and in accordance with design and contract requirements. Sorry, I forgot to slip a slide there. Why do we do it? HD inspection is important. While we implement engineering principles and industry best practices to design and execute the crossings, the reality is that field conditions can introduce unexpected challenges. Quality HD inspection can strengthen the ability to adapt, manage risk, and improve the outcomes of the project. By verifying compliance, catching issues early, and protecting surrounding infrastructure, inspection helps deliver safer, more efficient projects and helps avoid setbacks. There are three main phases to the inspection lifecycle. Consider them to be pre-construction, execution phase, and the post-construction and closeout phase. So over the next few slides, we'll dive into each of these phases. We'll discuss how the objectives of them, key activities, and the value that they bring to ensuring quality and reducing risk throughout the project. So while HD inspection is often thought of as something that happens early, only during the execution phase, I want to take some time here today and discuss and highlight why involving a qualified inspection team early in the design and planning process can make a really big difference to the project. Early engagement with subject matter experts will help identify potential project risks, align expectations, and ensure that the design and scope are fully understood before work begins. This is a proactive approach that can save time, reduce costly surprises, and set the project up for a smoother execution. Towards the end of the project, I'll provide some real-world examples of where this has been effective and some where it was not implemented and possibly some of the risks that could have been avoided. So before the equipment ever arrives on site, there are several details that need to be confirmed on the ground. This is where early engagement really pays off. One of the things we consider is access and right of way, not just whether we can physically access the space, but whether it supports the movement of the crews, the pipe stringing, large trucks, trucking, and turnaround. That ties directly into workspace requirements and pipe laydown area, which can be tight in urban areas, like the one shown here in the picture. We assess the staging areas and logistics. If there's no room for fluid tanks, mud mixing equipment, the drilling rig, tooling, back trucks, the drilling plan might need to be adapted and adjusted before it ever goes to execution. By engaging subject matter experts, inspection personnel, you can gain some real world boots on the ground experience to help plan for these situations. We assess equipment, staging, and logistics. When there are environmental and seasonal conditions such as wildlife, windows, freeze-thaw cycles, soft ground, restricted work hours, all of these things affect the project. We pay close attention to traffic and public interface. HD is often done in neighborhoods, near businesses, or along the roads, so planning around safety and community impact is critical. By bringing inspection in early, these issues are identified up front, expectations can be aligned, and avoid surprises that can cause delays once we are in the field. Also, a big part of the pre-construction is the design review. Bringing your construction management team and inspectors in early to help validate design is a very key critical part of the design and planning process. Validating the proposed bore path and assumptions in the design package is realistic and achievable from a construction standpoint. We begin by confirming that the bore path geometry, checking the radius, clearances, and alignment to ensure design fits with practical drilling limits using real-world experience. We then take constructability into in a general sense, even without knowing that the contractor, we can still flag concerns related to workspace, expected steering challenges, and geotechnical transitions that may require design adjustments. We review the geotechnical information to confirm the design accurately reflects the likely characteristics of the ground. If there are gaps or inconsistency, this is the time to address them. Doing these verifications early means that the final tender package is clear, accurate, and can be better aligned with how HDD can be built in the field. Risk reviews are a great opportunity to bring your inspection group in. They add field-based perspective and can quickly flag issues like access, site conditions, steering challenges, and equipment concerns. Inspection also can also identify practical site-specific factors that may not be obvious from a desktop review. By catching these risks early, we can build up mitigation measures into the plan, reduce uncertainty, and set the project up for success and a smoother execution phase. Execution review. This step's all about making sure that the execution plan truly aligns with the design intent. Early inspector involvement helps verify that the contractor's planned approach, equipment, and staffing capabilities align with the project. We also validate schedule feasibility and thoroughly assess the risk mitigation measures that the contractor intends to use. Just as important is confirming that the plan aligns with the contract, including scope, deliverables, reporting, and safety requirements. We assess the change management process. If anything in the field deviates from the plan, we need a clear, structured way to document it, get it approved, and track its impact. When these checks happen early, it reduces misunderstandings and avoids scope creep, and ensures everyone walks into the execution with the same expectations. Contract and scope review. A thorough review of the contract scope early in the process ensures that everyone enters the execution with the same expectations. We begin by verifying that the contractor's planned approach aligns with the design intent and the defined scope. We also review what's intended and excluded, because misunderstandings here often lead to disputes later. Contractor submittals like execution plans, rig specs, and staffing are reviewed for feasibility and alignment with contract. Another key step is identifying any gaps between what's written in the contract and what's realistically feasible in the field. We establish expectations around documentation, communication, and change management. Having clarity upfront reduces surprises and provides the project with a smooth, consistent path to execution. During the execution phase, the inspector becomes the consistent eyes and ears on the project. Their daily on-site presence helps ensure that drilling activities, safety practice, and environmental controls are all being carried out as planned. A key part of this role is documentation. Every activity, parameter, and change gets recorded. That record becomes the factual, time-stamped history of the job, which is essential for transparency, troubleshooting, and contract alignment. Inspectors are also the front line for safety and compliance verification, ensuring that the procedures align with both project requirements and regulatory standards. Finally, they serve as a central hub for communication. They keep information flowing between the contractor, the engineer, the mainline contractor, and the owner, ensuring everyone is aligned with what's happening in the field. Together, this is oversight, helps maintain control of the work and supports a smooth, predictable execution phase. Daily inspection. Daily inspection is where most of the inspector's time is spent. They're monitoring key field activities throughout the shift to understand the operation is progressing and identify any early indicators of trouble. The inspector also verifies the mud program by reviewing mud checks and verifying the drilling fluid is performing as it should. Steering tolerances are reviewed to ensure the alignment and radius remain within the design limits, and that any necessary corrections are documented and communicated. Additionally, safety and environmental checks are an integral part of the daily routine, ensuring that the crew works safely and that environmental plans and procedures are followed. Real-time data. A major part of the inspector's role during execution is monitoring real-time data coming off the rig. Metrics such as pump pressures, rate of penetration, fluids, and steering corrections indicate how the formation is responding. By watching these trends, the inspector can identify early warning signs, such as pressure spikes, losses or gains, or patterns in steering, before they develop into larger issues. This real-time insight supports timely adjustments by field drilling crews and gives engineering and the owner clear visibility into how the crossing is progressing. Having consistent, accurate field data ultimately leads to better decisions, faster reactions, and a lower risk in the execution phase. Reporting and documentation are integral parts of the inspector's role during execution. Daily reports capture key drilling activities. The inspector also documents the steering corrections and deviations, ensuring engineering and owner are aligned. Mud tracking may be included in the engineer's scope, or in the inspection scope, sorry, and involve the tracking and recording of water, mud, and disposal. Safety, environmental observations are included, along with photos and video that provide a transparent record of site conditions. Together, these documents become the factual history of the crossing, and it's essential for contract alignment, troubleshooting, and change management. Post-construction and closeout. Post-construction is where we confirm the work was completed as intended and wrap up all the documents. We then compile all daily logs, reports, and summary documentation into a turnover package that provides a transparent record of the crossing. Finally, we support contract closeout by validating the scope, execution, reviewing turnover packages, and helping reconcile any change or adjustments made during the project. Certification. So take a couple minutes here and we'll talk about some certification. There's some programs to help ensure that inspectors are going out qualified for the work, the value and the pros of having qualified inspection that are specifically trained for HDD as part of your project. So HDD inspector certification is the cornerstone of ensuring that quality and safety in HDD projects. Inspector training programs can establish a structured competency framework that goes beyond technical skills. Inspectors should be trained to meet a minimum standard of knowledge in HDD design, construction methodology and geotechnical interpretation, and environmental compliance while reinforcing professional conduct on site. Certification delivers measurable value to the owners by ensuring that HDD inspectors have a proven technical competency, safety awareness, and reporting accuracy. This reduces project risk, prevents costly rework, and safeguards environmental compliance. Owners benefit from consistent quality assurance, transparent documentation, and can have confidence that the crossings meet the design and regulatory standards, ultimately protecting budgets, timelines, and reputation. There's a lot of projects that everybody wears many different hats. HD is a very specialized industry these days with evolving technologies and advanced methodologies, and having trained, certified, competent inspectors on site with years of experience adds a tremendous amount of value to the project. So why inspection matters. Inspection plays a critical role in closeout, and it gives the owners accurate verified crossing information. The data becomes part of the permanent project record, and it's essential for future work, especially when planning parallel or replacements or expansions in the same corridor. Having reliable as-built documented data, performance checks, reduces uncertainty and strengthens the risk assessment for future crossings. Ultimately, inspection ensures you're not relying on assumptions or memory. You have a transparent, defendable record of what actually happened in the field. Sorry, I think I'm froze up here, guys. So there's the costs or risks of not having inspection. When inspection is missing or limited, the risk increases significantly. You're more likely to see design field misalignment or undetected issues. Without qualified inspection documenting activities, it becomes significantly more challenging to resolve disputes, validate contractor claims, or support effective change management. It also increases schedule risk because early warning signs are often overlooked. In the long term, you lose reliable crossing data that creates significant uncertainty when planning future work, especially for parallel or adjacent HDDs, where accurate as-built and crossing information is crucial. In short, inspection isn't just oversight, it protects the project today and reduces risk for tomorrow. So what inspectors don't do? We spend a lot of time talking about what they do and what they should do. And it's important to also identify what they don't do. So inspectors are not there to run the equipment, direct the drilling operations, or take over the contractor's supervisory responsibilities. They don't authorize engineering changes, redesign the drill path. Those decisions sit with the engineering team and the project owner. The engineer is there to document and escalate. Inspectors don't dictate production rates, tooling choices, or the contractor's drilling strategy, and they're not a replacement for the contractor's safety program or site authority. The inspector's role in oversight is oversight and verification and documentation, what's happening, identifying issues early, and keeping communication clear between the contractor and the owner. This ensures accountability without blurring the lines of responsibilities. Ultimately, the inspector is there to be the coordination between everybody, but not to be dictating the work. There are models where your construction management group can be hired to have that role, but that's a very specific contract structure where the owner will lean on the construction management group to provide and dictate drilling operations. However, for just general inspection, we work hard to not come across as dictating the work. We're there to support the contractor, support the owner, support the engineering, and ensure that everybody is aligned. I did get through those slides pretty quick. But we'll move into a couple of examples of where inspection would have added value and some where inspection has added value. And then we can go into the Q&A. So an example where inspection would have added value on a current crossing that's currently being designed right now, the owner has an existing right-of-way, and an HD was executed in that right-of-way about 8 years ago. And the owner is now looking to install a parallel line. And they've come to us for the design. And we were not originally part of the original crossing. They presented us with all the documentation that they had from that design of the original crossing and inspection. And the data and the information is fairly limited. So there's a tight right of way, and we're trying to design another crossing in it with very limited information and almost no knowledge of how the original crossing drilled. We're aware that there are some steering challenges just from the as-built data, but not sure what caused those steering challenges. Not sure if it was ground conditions, if it was the tooling that was being used, if it was bad drilling practices. So we're in a position now to have to try and sneak another line in and really go to the extreme to mitigate risks of being too close to the previously installed line. Had that project had more detailed, more clear, and more available inspection and documentation, there would have been a greater opportunity to review, understand why the as-built and why the pilot hole drilled the way it did, understand those challenges, and then ensure that they're not being incorporated into the current design. So unfortunately, we're in a position to review very limited information and then have to design the new drill very, very, very deep to ensure that there's no conflict with the original line, and that's going to force the crossing to be longer, essentially cost more money, and this would have been a very avoidable situation had the original crossing been executed with more detail and better documentation from the inspection side. An example of where inspection has added value. Looking at an upcoming project that's happening, there is be about the third time that this crossing has been drilled. The previous times they've had very good quality inspection that has been able to identify and track and document all the risks, project issues, concerns to highlight. So having all that information, not only are we able to design and plan for a crossing that's known to have high to almost all full losses of drilling fluids, it helps in also the RFP stage and contract development for the crossing as well. The owner is able to use the old information, have a very clear understanding of what to expect, what the real world drilling conditions are. They're able to incorporate that into the contract and into the RFP for the contractors. They're able to, this allows the contractors to put an accurate, realistic bid and proposal together, and everybody gets to be aligned up front. We're able to help the owner establish reasonable mitigations to try and gain circulation, but at the same time having the history that it's just not really possible in this area. A lot of time won't be wasted on trying to achieve something that's just not achievable. So rather than making assumptions that it could be drilled that way, the RFP, the contract documents are set up as such that the bid is being submitted to account for all the known risks that have been documented on previous attempts. This will allow the owner to get cost certainty and also some more schedule certainty. So rather than having expectations of a contractor tripping out time after time after time after time again to regain circulation where it's not possible, the execution is set up as such that, you know, go and no-goes are established early and the crossing can progress in a way that everybody knows is feasible. Yeah, so those are my slides. I did run through that there in about 30 minutes, unfortunately, a little bit quick, but we'll have extra time for some Q&A. So I think we're at that stage, Justin, to bring you back a little earlier, and maybe we'll be able to give everybody 10 minutes or 15 minutes of their time back.
Thank you for your presentation, Ron. It was an interesting one. So now we're going to move on to the Q&A session. We actually have quite a bit of questions in here already. So if you have any questions while we're answering the questions, you can type in the question and we'll try to bring it up like timely. So the first question is, what type of responsibilities would a construction management contract include versus a general inspection role?
What types of responsibilities would construction management contract include versus general inspection role? That's a great question. So looking at it as an overall construction management and not just the inspection role, we're often brought in by the owners to help develop the RFP and evaluate the contractors. And so we do a lot of evaluation on technical, and commercial. So we'll help the owner develop the RFP, and then we will be a part of the review process. And that review process will help the owner select a contractor best suited for the project. Beyond that, the construction management team is there to support the inspector. So the inspector should, be supported by multiple roles in the background with some additional oversight. We also help manage all the change management costs, and we can be involved in things outside of the HDD scope as well in terms of access and one calls, locates. We can take on prime status. So there's a big construction management portfolio that can be included as part of the inspection.
Thank you, Ron. The next question is, what are the most common issues in pilot hole steering that inspectors commonly deal with, and how can they be avoided?
Oh, most common. There's quite a few, I guess. We can run into utilizing the wrong steering systems for the wrong application. So there's a handful of different types of steering systems out there, and as part of the review from the construction management side of it, it gets carefully reviewed during the review process to validate that what the contractor is proposing aligns with the conditions that are going to be expected on site. There's always a lot of talk. Annular pressure is a big part of the pilot hole. So ensuring that the contractor has proposed the right equipment up front, is planning to have the right pump rates, bit sizes, and mud program, utilizing an engineering mud program, and then helping to ensure that they actually follow that in the field is a big challenge on some pilot holes. And as from the inspection group and construction management group, holding or trying to hold contractors to their plans that were approved can greatly reduce some of those risks. Obviously, geotechnical conditions or changing or unexpected geotechnical conditions can have a big impact on the pilot hole. So from a construction management side, we review the steering data, we work with the contractors, if they're having steering challenges, and then we work directly with the engineering groups to make sure that they understand the challenges and work towards coming up with solutions that can progress the crossing, such as an alternative alignment or relaxing radiuses, or if required, allowing a little bit more annular pressure to get the crossing executed.
Thank you. In terms of geotechnical, so for steering, is there any some kind of details or tips related to some challenging formation, if there's gravel or formation is too soft, anything like that? Would you be able to share?
Yeah, that's a good one. That's a good question. One that we run into, and I think we see a lot from our side, is when I say the right, is also not using the right tooling, and from a geotechnical side. So, it's in Alberta or North America, it's not very often that we get into a crossing that has one type of formation, and often contractors don't bring, let's say, a Swiss Army knife. They bring one set of tooling and expect that to effectively drill the entire crossing. So for example, if the top half of the hole is going through extremely soft formation, and you're trying to get in there with a mud motor, we see a lot of issues there where we're having frac outs because you're required to pump a lot more, and steering challenges because the BHA is heavy. So it'd be great. And one thing we try and identify that early in the execution review is that the contractors are bringing the right equipment to do the job. So there's oftentimes that you have to start the hole with one bottom hole assembly and complete it with another. Other key risks, obviously, for steering challenges could be gravel. During the design reviews, we try very hard to stay away from the gravel or ensure that gravel's cased at surface. And then also, when you have the bedrock interfaces, those have to be evaluated carefully too, going from the soft formation to the hard formation, ensuring that the design and the angles are such that the drill bit can effectively penetrate the harder formation below the soft formation, and then also that the drill string is supported in the borehole above it. So those are some key ones there. Gravel, interface between different layers and how they're executed.
Thank you, Ron.
Making sure that, as a part of the review, is making sure that the contractor identifies them and puts strategy to them in their planning. Greatly helps reduce some risk.
Sounds great, Ron. We have a lot of questions here, actually. I hope we can cover all of them.
Okay, well, good thing I got it done early then.
Next one, it's a bit general question. What situation would require microtunneling to use in lieu of HDD?
Well, that's an engineering, not an inspector question, but gravel, bad formations. Yeah, there's definitely some formations that the microtunneling or even direct pipe can be executed where HDD can't. Shallower crossings, different formations, depending on utilities. Risk of settlement is a big one as well. Good time to consider alternative methods like microtunneling.
Sounds good. To add to that, I think a slope requirement also important to decide whether to go for microtunneling or HDD.
Yep. Yeah, there's always a big trade-off with microtunneling is expensive, but it has its place, and in, you know, as part of the review process and going through the risks, if great deal of risks are identified, then that's when we want to start looking at alternative methodologies.
Thank you. Next one is, do inspectors ensure drillers have proper locates? So
part of our construction reviews and daily inspection is we do review ground disturbance. So we always ask ahead of time to get all the crossing agreements, the locates and sweeps, and then we include those as part of our turnover package. We include them in our documentation, and we do verify as best as we can. So as an inspector role, we're not directly responsible for getting the information, but we do support the project by reviewing and confirming that it's in place.
Sounds good. Another good question. If there are challenges on a particular project, when in your experience, have you seen the benefits of having the inspector on site versus not when negotiating changes?
So if I understand, the benefit of having the inspector there the entire time of the crossing versus just coming in to manage changes, yes, that there's a benefit there. It kind of ties back to the slide of when inspection would have helped. So getting the information upfront, collected documented, essentially time-stamped, as well as having the inspection and construction management group a part of the early involvement and the contract reviews and the scope reviews will help ensure that change can be managed. Ensuring that upfront the clear lines of what's included and what isn't included is identified, and that the plans reflect that accurately. It's really difficult to come in after the fact. It does happen from a construction management group's perspective. We do get those requests to review crossing history and then comment on whether, I guess, change orders are feasible or not feasible, sorry, valid. But it's a lot more difficult after the fact.
Sounds good. The next one is, to what extent do you survey or use ground radar to detect existing utilities or pipes? Is this what you guys do as well?
So this would be part of the ground disturbance up front. So it depends on our role and the scope that we're involved in. If we are requested to have either prime or status, or if we're, brought to site and it's just part of a construction management perspective, then we could be involved and facilitate doing one calls and sweeps and ground disturbance and ensuring ground disturbance is met. Ground penetrating radar can be used in urban settings to help verify it's getting any more and more popularity. But to what extent, I wouldn't be able to put bookends on when we would or wouldn't use it, I guess.
Sounds good. And I know your this webinar is recorded and it's going to be on our YouTube channel. But Ron, are you willing to share the copy of your slides? That was one question.
Yes. Yep. Okay. That's no problem.
Then please forward the email to Ron, and then we'll probably send it to you. Next one is, what are something that can go wrong, and how are they addressed on site? It's a broad question.
What are some things? Well, lots of things can go wrong, I guess. Yeah, I don't know where to start with that one.
Too many.
Yeah, I mean, it's the biggest thing, I guess, for the most part, it depends on the pre-construction planning. So things can go wrong early on if there isn't enough planning in terms of site access and weather, and not planning for those things. We don't always work in the most ideal conditions. We work in winter, so this is where getting your construction management group in early, doing site visits can really help plan for trucking, transportation, staging areas, getting where to put the equipment. Is there enough space on site? Can the trucks turn around? Can they get back out of site? Is towing required? Is grading required? Is snow removal required? And then in terms of the actual drilling, the ground conditions are always challenging. So we do a lot of geotechnical reviews and inspections to try and gain the best knowledge we can when feasible. But often we run into unexpected ground conditions. And so it's being prepared for that. Having the right tools and the right experience and the right equipment on site plays a big part of that. Reviewing the information that's available on site, the drilling parameters, the data, the drilling fluids, and for them using that to get a head start on identifying when these risks and when troubles might occur, rather than, so I guess being proactive rather than reactive, I think is a key benefit of having experienced inspection and construction management on your site. Identifying things early and just assisting and being proactive.
Thank you. And talking about timing being important, I think the important thing to know is that you mentioned about early engagement and the timing to involve, especially I think writing something like a GBR, it's very tricky for something like HDD. Then it relates to what you guys inspect on the site, right? So what to incorporate ahead and then how to deal with the problem. I think that is something that a lot of people like us, we have question about.
Right.
Like what specific we can kind of like incorporate ahead, then risk is clearly identified, right?
Yeah.
All right. Then the next question is how many inspection help coordinate between the mainline contractor and the HDD contractor, if at all? Have you seen instances where there were delays in projects due to ineffective coordination between the mainline contractor and the HDD contractor?
Yeah, that's a great question. So earlier on, I mentioned that we act as a communication hub. Oftentimes, the inspection groups will attend the morning meetings that will involve all the contractor, the contractor, the mainline, and owner representatives. We not only document what's happening that day, we're giving forecasts, daily updates, and planning to ensure that mainline is prepared for what's coming next, essentially. So one key takeaway there, you could look at the pipe pullback. Oftentimes we need extra subcontractors and like cranes to be a part of the pipe pullback, and you typically can't call Friday night and ask for 7 200-ton cranes to be on site Saturday morning because you're ready to pull pipe. So there's a lot of coordination that flows through the inspection group that helps ensure that everybody's aware of what's coming next and how we can be, 3 steps ahead and not see delays because of that. Often it's happened more on a lot of occasions where the rig is sitting for a day or two because we have to wait on the support to get a pullback done, and that puts the whole risk and often would require additional swab passes.
Sounds great. Next one, I actually had this question too. Is there an HDD inspector accreditation program? Like, is there anything like a formal process, or like how does the training goes? Or like if somebody wants to be HDD inspector, like what would you recommend to prepare?
Well, I guess I get to sell at CCI a little bit here because it was asked, but CCI does have the HIT program, the horizontal inspector training program. So there is there are some formal training avenues out there. If anybody's interested, definitely reach out to me or go to the website.
All right, sounds good. As an inspector, how critical is it to get the drilling information, for example, mud pressure, pilot bore depth, alignment, offset in real time? This is tough to get on site, even if it's in your spec. Is it okay to receive daily or at end of the day?
So the inspectors on site, typically, and hopefully we have an inspector on site for the duration of the day. And the inspector will probe, let's say, the contractors as often as required to try and get the information. A lot of contractors are used to it and know all the inspection groups quite well. So there's always the hope that that's a very smooth process, I guess, to get the information. But it is critical to be up to date and understand what's going on with the hole in the rig. we don't run the rig, as I mentioned, and we don't dictate how the drilling is going, but getting the information early does help the inspection group understand what's happening and be able to provide quick suggestions and communications to the owner.
I guess it's case by case, but how many inspectors typically require for site? Because I see from your slide, you guys do so many things. So just curious, especially when it's like a long drill, right? I have to walk all the way all the time. Just curious about it.
So it depends, and it's site specific. You know, for major crossings, we like to have an inspector on site on you know, day shift and night shift if there's two shifts, and we possibly on entry and exit depending on how far apart they are, if there's an intersect being proposed, or what the construction methodology is for that crossing. There are scenarios where one inspector can oversee a couple of smaller crossings that are happening at the same time. So it's project specific, and you know, the more you have, the better, and the more accurate the data and real time reactions can be.
Sounds good. Next one is, how often are calibrations done on the equipments? For example, like drill rig.
There's no set standard for that. There's been some projects in the past where an owner has required that the drill essentially undergoes like a pull test. It's kind of an owner specific requirement. I haven't seen it a lot. There's a few times in the past, and I've been involved in developing a process for doing that. But the steering tooling and guidance equipment is calibrated and inspected often. But as far as the actual drill rig and yeah, it's I wouldn't say it's a lot. And then downhole tooling, drill pipe, reamers, bits, and all that stuff is also inspected very often.
Sounds good. How many space is needed for setting up the drill?
That depends, I guess, a lot on the crossing. A big crossing, you know, what we would consider a major crossing with a maxi-sized drill rig with all the support equipment, we typically shoot for about 60 meters by 60 meters. And then you can go down to, you know, a little fiber optic rig that just essentially needs the size of its own footprint and a truck to support it. So it ranges quite a bit on what the crossing is and the size of the equipment that'll be required to execute it.
Sounds good. Maybe one more question. What kind of a safety check is required for HDD? What are those like type of safety hazard can happen during the HDD?
Well, yeah, there's lots. So, you know, we're working outside. So there's wildlife, there's weather, the drillers, locators, and frac walkers are walking, you know, uneven grounds, terrains, steep slopes. You could be working in urban areas where there's traffic, or you're, you know, maybe you are the hazard to the public and the local area. So there's mitigations to put in place for that too. So, you know, heavy equipment, trucking, driving is the most dangerous thing we all do. We always hear it. Rotating equipment, pinch points, lots of hazards. So a big part of the inspection is to help identify those, make sure that they're being mitigated, and identify and bring attention to anything that could put anybody in harm's way.
Sounds good. Thank you. That was all the question. So appreciate Ron for
one minute
giving good presentation and all the Q&A. And before finishing, I would like to take a moment to thank all the QIC members listed in here. And thank you everyone who came to today's presentation today. And I hope you enjoy your rest of your day.
Thanks, Justin.
Thank you, Ron.